Imagine that tomorrow an asteroid the size of a city slams into the Earth, or a supervolcano awakens and shrouds the planet in ash, or we ourselves, in a fit of madness, trigger a nuclear winter. What then? The end of the story. But what if I told you that right now, at this very second, humanity is building itself an escape hatch, and that this exit is located 225 million kilometers away on a cold, dead, red planet? Have you ever wondered why everyone is suddenly talking about Mars? Why visionary billionaires are spending fortunes on rockets and scientists are seriously discussing the transformation of a lifeless desert into a new Earth? The answer is simple and terrifying. In the 4.5 billion years of our planet's history, life has never once left it. As far as we know, we are locked on a single spaceship called Earth. And if something happens to this ship, that's it. Finito la commedia. The idea of interplanetary life has ceased to be science fiction. It has become a roadmap. Thousands of ships, millions of tons of cargo, a self-sufficient city on another planet. This is happening right now. In the deserts, spaceports are being built where new starships the size of skyscrapers are assembled every few weeks. The goal is to produce 3 such behemoths a day, every single day. But is it really that simple? Build rockets and fly away? Of course not. Mars is not a resort. It is a radioactive desert with no air, where the temperature drops to minus 125 degrees Celsius and the entire soil is saturated with poison. Today, we will delve into 3 fundamental things. First, why Mars and why now? Second, how is it even possible to turn a dead planet into a living one? And third, what are the real plans and how feasible are they? The stakes are high. Living on Mars is not just a scientific experiment, it is a matter of civilizational survival. It is our backup, and we may have less time than we think. Part 1. The hell and heaven of the red planet. There are 8 planets in the solar system, so why are we fixated on Mars? The answer lies in a stunning paradox. Mars is both a hell and a heaven. A hell because it is ruled by cold. Its atmosphere is 100 times thinner than Earth's, and the radiation will kill you. And a heaven because only Mars, of all the planets, bears any resemblance to our home. A Martian day is almost equal to an Earth day. The axial tilt provides familiar seasons. The gravity, though weaker, is sufficient for life. On the Moon, for comparison, gravity is 6 times weaker, posing a serious threat to bones and muscles. But these are technical details. The real reason for the obsession with Mars is much deeper. In its history, our planet has survived 5 mass extinctions. 5 times life has almost been completely wiped from its face. The last time was 66 million years ago, when an asteroid the size of Mount Everest destroyed the dinosaurs who had ruled the planet for 170 million years. They vanished in an instant. By the way, the dinosaurs lasted 850 times longer than our species, Homo sapiens, has existed. But we have something they didn't: the brains to understand the threat and the technology to do something about it. And today, the main threat is us. Nuclear weapons capable of destroying civilization 10 times over, artificial intelligence that could spiral out of control, climate change already altering the face of the planet, biotechnologies capable of creating a supervirus. A civilization on one planet is a game of Russian roulette with a fully loaded revolver. A civilization on 2 planets is an insurance policy. The probability of the simultaneous demise of 2 worlds approaches 0. And most importantly, Mars is reachable. With current technology, the flight will take 6 to 9 months, a long time, but the first settlers of America sailed across the Atlantic for about the same duration. Part 2. The frozen laboratory and the cosmic gas station. But Mars is not just a second chance. It is the greatest scientific laboratory scientists could ever dream of, an entire planet preserved in time. On Earth, Plate tectonics and erosion have erased the traces of early history, but Mars froze billions of years ago. It's like finding a photo album of the solar system's childhood. And you know what they've already found there? Traces of water. A lot of water. Once rivers flowed and oceans splashed on Mars. There are suggestions that water still exists in liquid form beneath the surface. There might be enough to cover the entire planet. And where there is water, there is potential life. If even fossilized microbes are found on Mars, it will revolutionize our understanding of the universe. We will understand that we are not alone. And we are already reaping the benefits. Just by preparing for Mars, we're inventing technologies that are changing life on Earth. A device that produces oxygen from the Martian atmosphere, aeroponics technologies for vertical farms, increasing yields tenfold, new materials for spacesuits that protect from radiation, 3D printers that print bricks from local soil. Now for what is usually spoken of in hushed tones: money. At first glance, Mars is a financial black hole, but that's not the case. Mars is damned rich. Iron, titanium, rare earth metals, it's all there in industrial quantities. And also water, from which you can make rocket fuel. Imagine an economy where Mars is the cosmic gas station on the way to the asteroid belt, where every asteroid is a flying mountain of platinum. An economy where resource extraction is moved from the fragile Earth to lifeless space. This is precisely why private companies and entire nations have entered the game. But there is also something intangible. Mars inspires. The flight to the moon prompted an entire generation to go into science and engineering, ensuring technological leadership for decades. Mars can play the same role today, becoming a new grand project for all of humanity. And one last thing, the window of opportunity may soon close. A new world war, an economic collapse, or a pandemic, and the Mars plans will be postponed indefinitely. And there may not be a next chance. So the answer to the question, why now, is this: because we can, because we must, and because if not now, then possibly never.
Part 3. Terraforming, the planet-altering plan. Let's say we made it. We built a base under a dome. So what? Live like that? Forever hiding in tin cans on a dead planet? No. Humanity has a bolder plan. Terraforming. The plan to turn Mars into a second Earth. The history of this idea began in the 1940s in science fiction, and in the 60s, the great Carl Sagan seriously proposed seeding the atmosphere of Venus with algae. The plan failed, but the ice was broken. Scientists switched their focus to Mars. The ideas range from the conservative to the completely insane. Plan 1. Global warming on steroids. We build giant factories on Mars that produce super greenhouse gases millions of times more effective than CO2. The atmosphere thickens, the planet warms, the polar ice caps melt. The problem? Where to get the raw materials on a planet with almost nothing? Plan 2. Cosmic billiards. We direct asteroids of frozen ammonia at Mars. Boom! An instant release of greenhouse gases. The problem? Ammonia is quickly destroyed by ultraviolet light, so the planet would have to be constantly bombarded. Plan 3. The artificial sun. We put giant mirrors in orbit, 250 kilometers in diameter, that focus sunlight on the poles. Elegant, but the cost of delivery and assembly is in the hundreds of trillions of dollars. A cheaper option? Millions of small solar sails that will gradually heat the planet. Plan 4. The nuclear option. Just nuke the poles with thermonuclear bombs, creating 2 artificial suns. An idea that so appealed to some visionaries that they even released t-shirts with Nuke Mars printed on them. The problem? Even if you melt all the ice and vaporize all the gas from the soil, there still won't be enough atmosphere. Plan 5. Biological warfare. We drop genetically modified extremophile microbes on Mars that will consume CO2 and release oxygen. First microbes, then mosses, then plants. The problem? This will take from 1,000 to 100,000 years. We don't have that much time. But there's an elephant in the room. Mars's lack of a magnetic field. The solar wind will simply blow away any atmosphere we create. The solution? Create an artificial magnetic field with a giant electromagnet in orbit. Technically possible, but energetically and logistically, for now, beyond our grasp. Most likely, humanity will choose a hybrid approach. It will start by terraforming small oases under domes of aerogel, a material like frozen smoke that lets in light but traps heat. And then, we'll see. Part 4. The Cosmic Ballet and the Robot Armada. But all these plans will remain fantasies without one key element, a serious transportation system. We need ships, thousands of ships, a whole fleet. And here, a technology without which interplanetary flights are impossible takes the stage: orbital refueling. To escape Earth's gravity well, a starship burns almost all its fuel. It reaches orbit with nearly empty tanks. To fly to Mars, it needs hundreds more tons of fuel. The only option is to deliver it there. The plan looks like a cosmic ballet. First, a ship with cargo is launched into orbit. Then, one by one, tanker ships are launched to it. They dock, and the most difficult part begins. Two 100-meter ships connected together begin to rotate slowly to create artificial gravity and press the fuel against the tank walls. Then, cryogenic pumps transfer liquid oxygen and methane. For a full refueling, 5 to 8 such operations are needed. The slightest mistake, and two ships worth hundreds of millions of dollars will turn into a pile of scrap metal. This is precisely why all previous Martian missions were so small. A car-sized rover is the maximum that can be sent to Mars without refueling. Orbital refueling changes everything. It turns a heavy rocket into a true interplanetary transport. And who will be the first? Not humans, robots. Humanoid robot avatars controlled by the same AI as self-driving cars. The first ship will deliver dozens of such robots to Mars. They will unload cargo, install solar panels, and prepare the landing site for the next ships. By the time humans arrive, the basic infrastructure will already be in place. Imagine the epic moment a humanoid robot takes the first steps on Mars. This will go down in the history books. And then, exponential growth. 10 ships, 50, 1,000, 1,000,000 tons of cargo in one launch window. That's enough to build a real city. The site has already been chosen, the Arcadia region. Not too cold, not too hot, flat terrain. 10 years ago, the world laughed at the idea of landing an orbital rocket vertically. Today, it's routine. History teaches us, when visionaries say it's possible, one should at least not be quick to draw conclusions. The question is not whether we will colonize Mars. The question is whether we will make it in time. Conclusion: the countdown. So, why do we need to go to Mars? Because it's our only insurance policy. Because it's the greatest scientific mystery. Because it's the engine of progress. And because we are explorers. Throughout our history, we have always gone beyond the horizon. The next logical step is another planet. The next launch window is approaching. The clock is ticking. See you on Mars.